All right, folks, when we left off, we had just gotten part of gRPC core to build by hacking together this Bazel rule that builds libareas and makes it a shared library. It's hacky because what really should happen is that rules Haskell should be extended to cover the case where always link is set to true on C libraries. I spent about maybe like 15 minutes trying to see if I could hack together a pull request to rules Haskell. I wasn't able to get it done quickly. I started realizing that I would have to dig into the implementation details of not only the handling of the CC dependencies, but also the rules Haskell dependencies, because of the way that the logic in rules Haskell they kind of create their own CC object within the rules Haskell object. And I'm not positive that object that they create has all of the information I need to populate the areas dependency properly. So I left an update on the PR issue, which should be enough for the rules Haskell people who know the code base better to implement that. So I may decide. Hopefully they will. I don't know what their roadmap is like. What else they're working on. This might be a low priority for them, but it would be cool if they could do it. If they can't do it, I may at some point, like in a year or two, make it work. But that might be part of an overall larger cleaning up of the rules Haskell rules for my use cases. And so if I'm going to invest the time in kind of getting to know what they're doing internally, then I might do kind of all of that cleaning up as a bulk operation. So I guess let's go ahead and try to build the rest of Haskell core. The build failed. And it fails on unsafe. And the analysis fails. C2HS library. Sources field should contain exactly one file. Okay, so let's go ahead and fix that. So I guess these are all CHS stuffs. So what I want to do is, for each of these, create their own CHS library. So I want to just grab this whole thing, rename it something to indicate that I'm going to delete it, get rid of all this stuff. Let's see if we can edit all these at the same time. Oops, I did something wrong because I've closed these parentheses. I don't know if that's an Emacs mode that, no, something wrong with my macro. That's okay. Just pick a new macro. Okay, I don't think I need the empty depths. And something went wrong here. Let's see how that likes that. Yeah, it doesn't like that there's no names. So I don't think my macro foo is good enough to give everything the appropriate name. But I'll see what I can do. Not bad. And then we'll just get rid of the unsafe slash. And get rid of this delete me thing. So now each C2HS library has its own, is wrapped in its own rule, which seems to be what this wants. Now the dependencies aren't in there, but they should be. Unfortunately, we're getting some run GHC error. And we were erroring in Cabal wrapper, again, with the Python files, unfortunately. And what we're failing with is zlib. Now, who's depending on zlib? What rule is it trying to compile? I'm not sure. Why don't we why don't we try compiling just unsafe? Okay, so build completed, and it did not complete successfully. We exited abnormally. So is this what's failing with zlib? Include libdir in include path, just like HS2CHS does. So is this still failing with zlib? Okay, so time.chi is not found. So I think we're running into the issue I just mentioned, which is that we have a build order. Let's try building time. Let's not be so lazy. Let's actually look up which of these files depends on which others. Where are we? Source network, gRPC, unsafe. Where's unsafe? Oh, we're in core, right? Source network, unsafe. So does time depend on any of this other stuff? So importing some stuff, but this, I don't think these are in. Oh, okay. So unsafe should depend on everything, right? Yeah. And import of the C2HS stuff is in these brackets. That's useful for scanning the file. So let's build. Let's start by building time. Just work up from there. Include anything here? No, looks good. All right, so time. Failure. Okay, so we can't find gRPC/support/time. I could probably make it depend on this gRPC target. I'm pretty sure this always link behavior doesn't need to be here, actually. In fact, we're going to delete it and verify that constants still builds. Yeah. So constants builds. It's not surprising. We'll op build. Okay, so I tried to compile op, and op depends on slice. I bet if I try to compile slice, then it will fail with some gRPC error, which it does. So let's just try making gRPC bits a dependency on slice. What is it, gRPC bits? I'm guessing this will not work. Can't find gRPC-haskell. And we're including with angle brackets. So let's make sure that that's not the case. So all these angle brackets will all these angle brackets will replace with quotation marks. This might be faster. Okay, and then slice. How about, what is it? Do query replace. Okay, and then we'll save all that. And let's do it again. And we will replace, I guess, .h bracket with .h quote. I think that should not be too broad. I don't want to replace a legitimate .h bracket in the Haskell code. I just want to replace the includes. Okay, so now let's see if this will compile. No. Okay, so still can't find this include. Which is a problem because we do have this dependency on gRPC bits, which has the header. So why is it not seeing it? Do I have to add? Not sure. Maybe it's just the path. I think that I have to do the include from maybe the root of the directory. So let's try core cbits, gRPC-haskell. Okay, so it likes that. All right, so slice builds. What about, who knows? What about time? Not sure whether it's best to just do one at a time or just try to build the top level and see what goes. So slice builds, but I don't think slice should build because slice has a dependency on gRPC. And that's not explicitly put here. Is that the right behavior? Everything that's everything that slice imports should be in the dependencies. I don't remember what the CC rules do. If one of your dependency includes the others. But ideally, it would fail. I don't know if that's just because that's how the compiler works, or if rules Haskell is doing something funny with the the CC dependencies. So let's try in slice, let's try getting rid of, let's try, first of all, explicitly adding another dependency shouldn't matter at all. Let's just verify that. Then let's try removing the cbits dependency and see what the error is. So we can't find cbits. That's understandable. Now, what happens if we move both? Does it fail with the same exact error? So now I can't find slice. So at least, oops, at least if we have the gRPC dependency, then we find the gRPC import. If we have both dependencies, we find both. But that's a little bit unfortunate because it would be nice if the build system forced us to list everything that was a dependency and didn't succeed because one thing imported the other. All right, so slices should depend on both of these things. Time, I guess, should depend on at least gRPC. Okay, and now well, let's try time. So time depends on unsafe. Wait, what? CHI. What did I try to build? Security? So security is going to import unsafe. But I thought we were in unsafe. Unsafe op, unsafe channel args. Unsafe CHS, that's what it's importing? Let's try building unsafe then. So unsafe depends on time. Time depends on gRPC-haskell. Let's try compiling time directly just to make sure that this is the issue. I thought I built time. Maybe I didn't. Okay. Cool. So I think time needs to depend on the cbits. So time requires importing gRPC-haskell. And it's not where it expects to find it. See how many people import this ghc-haskell.h. So we've got a few of them. And so we can do something like direct query replace thingamajiggy. We're going to replace gRPC-haskell.h. No. We're going to replace the whole include statement so that we don't overzealously replace things with the proper location include station. And we forgot to mark files. We'll save all the files. And then maybe that's going to fix that issue. Go to the compilation window. Try it again. All right, so time compiles. Let's see just what compiles. So something can't find slice. What is it? What is it? Byte buffer? I guess maybe it's going to try to compile in alphabetical order. So byte buffer, we're going to include slice. Channel args. Is there a faster way to do this? I don't know. And we need to include the C gRPC library. And while we're here, let's take a look at channel args. I might be missing a couple here or there, but at least this will get us started. Let's go ahead and make an Emacs macro to create the necessary depth lines. Just so we have a place to stick our dependencies. All right, and so channel args needs to depend on what? So it needs to depend on gRPC. It needs to depend on gRPC-haskell. So I'm going to grab these two depths. And anything else? Well, we've got these import statements, but I guess we'll handle them later. And time, I think I did. Slice. You know what? I added these to the wrong thing. Didn't I? Okay, what about metadata? So metadata needs both gRPC and gRPC-haskell. Well, op. Op needs both as well. But it also needs slice. Byte buffer. And metadata. What about security? So security depends on unsafe. It seems, I guess that's fine in Haskell. Channel args, metadata, op, and also the two gRPC things. And what's next? Slice, it looks like we got a lot of depths. Messed that up somehow. And I think time, we got building and constants builds. So let's see where we are with that after those changes. Slice.cha slice.chi is not found. Okay, and so what is it trying to build? Metadata? Did it need to depend on slice? I don't think I saw that. Yeah, okay, it does. Is it a typo? Okay. So we need CHS time to be imported in time. Where is that imported? Didn't time build though? Oh wait, hang on. Okay, so now it's trying to build CHS time. Okay, what is that? I don't know. Maybe unsafe. So what? The unsafe.chs. Oh, not sure yet what is the actual failure. Let's try. I think it's failing to build unsafe. So let's try just building unsafe directly. And we get C2HS. Time to CHI not found in core/CHS dash time. Well, it should be. So we have unsafe depending on time. I'm wondering if this is a path issue. Maybe it needs, maybe this is a conflict between the fact that the directory starts with source here and it's looking for something based not on the directory, not with source, but based on, I guess just the package. Is that what that is? Slice? Yeah. So I'm wondering, so this layout was created by Gazelle, but maybe Gazelle doesn't know that it's supposed to be, maybe the C2HS rule is assuming something about package layout, and that's not being, Gazelle's not aware of that. So let's try moving this file to inside the source directory, which would be slightly better than where it is because ideally the build file would be there'd be a build file in the directory of all of the source files. So let's try moving this into the source directory and see if we can do build unsafe here. Now that might break some other stuff because now everything's looking in source. Invalid. So now the toolchain is wrong. Maybe, where is that? In the... So maybe that's configured in the workspace file. Or maybe it's in the root build file. So while resolving toolchains for target core source unsafe. No such file package core. Maybe we need an empty package in core. Let's create an empty build package in core. This should still fail because is looking for stuff in the source directory. Let's try building just unsafe. Core source. Okay, so core stackage. So somewhere I've configured. Oh, here it is. Okay. So now we're getting some missing input stuff, file stuff, because gRPC-haskell.h core source. So we might have to change the gRPC-haskell input, but at least here we should be able to change this and see what happens. Where's time? Okay, so cbits. Cbits needs to go here in the below source. First one, I don't need rules. I don't need CC binary. Okay. And now everything that depends on cbits will now need to point to the right thing, which is what? Core gRPC cbits. So now we're getting a visibility issue. Let's make sure that things are visible. You can set the default visibility, something like package
make it publicly visible. Go back to compilation. And I have a syntax error, probably unquoted. It didn't terminate the C quote. Okay, but we're still getting this byte buffer thing. Oh, no, this might be a different issue. Now we're looking for byte buffer. Let's just try replacing source slash with nothing. Do I want to do this? I guess so. So byte buffer.chi. Does it depend on byte buffer.chi? Let's try building time. So time works. Okay, and so let's take a look at unsafe.chs. Does it depend on byte buffer? Yeah, it does. So somehow I missed a bunch of dependencies. Twice. And it can't find gRPC-haskell. Or byte buffer can't. So byte buffer needs to depend on the C bits. And unsafe needs to depend on the gRPC C library. And I guess also the C bits. Oh, you know what? It's not just that. It's that unsafe is depending. It's that unsafe has the wrong import statement still. I thought maybe I had this already queued up. Something like this. Now we're getting an unknown identifier. Can't find a definition for gRPC insecure channel create in header file. And maybe that's because the insecure channel stuff has been removed. So remember, we upgraded to a version of gRPC that I said might not be supported. So let's see if there's anything on the internet about this insecure stuff. I don't want Juniper. So it's in this gRPC.h include file. Can I go to the current file? How do I go to the current one? Oh, Lord. Here? Okay, so somewhere we seem to have lost the insecure port line. Line 565. Add HTTP2 over plaintext. So, when was it removed? Let's try 42. So it's here, still here in version 42. Let's check in version 56. Not here in 56. So what about in version 46.6? No. Oh, 45? Where did I establish it was there? Somewhere between 41 and 45, it disappears. So how about 43.2? It's still at 44. Did I look at 47? Not in 47. I think you looked at 45, right? Okay, so between 44 and 45, it disappears. So maybe let's check the release notes for 45. Maybe I don't even really need to find it. Maybe I just need to roll back to version 44. But I think that this is possibly what's causing the problem. Let me just double check the workspace. So 155. Let's try 144. I'm going to guess. Oops. So I'm going to guess that's not going to work. The SHA is going to be wrong. Oh, it's looking up the SHA and finding the version 5. So let's grab the right SHA. And presumably we'll have to rebuild everything from scratch. Resolving select keys for UPP. Analysis of target Bazel Tools platform window failed. Okay, so I might have to declare some platform dependency thing. So I guess I'll figure this out in a little bit. We'll try setting an explicit Bazel version. Try 5.4.0. All right, so that worked. Let's try building all of the things in source. I'm still not expecting this to work because some of the dependencies might be broken. So we're missing some dependencies, it looks like. gRPC.hs needs to depend on unsafe. But I think that means that if unsafe builds, I think that means all the C2HS stuff builds. Is that right? Maybe? Okay. So we have low-level op here, which is different from the C2HS op. And so what's it trying to build? gRPC.hs, which is in gRPC-haskell core. So I think that's what's failing. Let's double check by trying to build gRPC-haskell core explicitly. I should get the same error message. Yeah. Okay. So we definitely at least need to depend. Wait, hang on. We do depend on unsafe. Network gRPC unsafe. Cannot find module. I wonder if this cannot find module is related to the path issue now. Let's take a look at the paths again. So in core, we have the cbits thing, but everything should be in source. Low level. We have here op.hs. Let's also maybe get rid of these things. As an experiment, I'll try making another Haskell library that is basically this library with just some of the features. Maybe let's try call. Although call will probably depend on unregistered, right? Let's try just call unregistered with no dependencies and see what happens. Okay, we get an if def debug issue, parse error on input. I believe what I need to do is make it run the C preprocessor. It's not, this file isn't telling it to run the preprocessor. So I think I just have to turn on that extension. Okay, now I'm getting that it's missing a dependency. It's missing some dependencies, like on low-level gRPC, completion queue, and a bunch of other things. So this isn't the nice. This is. Let's try something that might have fewer dependencies. Same as if def debug. We'll just copy it from here. I have a feeling I'm going to have to add this to virtually everything. Okay. Same dependencies. Completion queue internal, foreign pointer. So a bunch of these I can add. System clock, unsafe byte buffer, low-level gRPC. But maybe low-level gRPC is where I want to start. Let's try low-level gRPC. All right, if def debug. Okay, so now we depend on mostly stuff in unsafe and things that are not, things that are in stack essentially. So we'll depend on unsafe and we'll grab, actually, let's just grab all of these for now. I don't know whether we need gRPC, so maybe we won't grab that one. Let's see if this will work. Okay, we need unsafe op. And let's make sure this is called something like low-level gRPC. But so why can't it find unsafe? It's the C2HS library here. Network gRPC unsafe. We also need metadata map. Let's try metadata map. Maybe for some reason it's not finding unsafe because once it fails with something like metadata map is not proceeding.
We'll start with no dependencies for metadata map. Input file does not exist. Doesn't it? Oh, we need another gRPC. Okay, so now we need some data map strict data list. Are these in base? Let's add base. Oh, it's in containers. What else do I need? Base, byte string, and containers. Okay, so I have base. Let's add byte string. Okay, well that compiled. Well, that's good. Let's try low-level gRPC again. We need unsafe op. It also can't find metadata map. But why? What if here I put the full path to unsafe? Is that going to matter? What if I make unsafe a source? Oof, it seems to have progressed. That's ugly. It wants it to be sources. It wants these dependencies to be sources if they're C2HS dependencies. Where's unsafe time? Is unsafe time just the same as time? Yeah, there's a bunch of, this doesn't seem like a, Haskell rule seems to make a lot of choices that are not really consistent with what Bazel is supposed to do. I may end up just vendoring it and making my own changes. Okay, so I can't find slice. Can't find constants or op or metadata or channel args. So constants doesn't produce any sources. But HSC. Maybe I need to depend constants as a depend on constants as an actual dependency for some reason.
Because maybe it's not C2HS, it's just HSC. Okay, this seems to have made progress. But now it's the error. We need metadata map, which should be a standard dependency. Metadata map does not exist. Well, I spelled it wrong. It does exist. I just spelled it wrong, man. Okay, we also need unsafe byte buffer. Okay, so I think that maybe it's thinking of these possibly as sources in analogy to what to how C++ treats headers, but I don't think that that seems wrong to me. Okay, so these should be dependent. All right, so now at least that builds. And in fact, that might be enough to build everything. Let's try adding these to sources. Did I remove? I don't know if I removed anything from gRPC-haskell core. Here we need constants. We can add constants. And we need to add some more C++ preprocessor directive, not directives. Need to enable the C++ preprocessor. And we need unsafe security. All right, so gRPC Haskell core builds. I'll delete these little libraries I created. And let's try to build the whole everything. Yeah, everything builds. Look at that. Cool, cool, very cool. Okay, so let's see if we can build the rest of everything. Now it should just be a matter of setting up the dependencies properly. If there's any real interesting debugging, I'll chime in, but probably I'll just do this in silence as a montage. unfortunately, because of the way that they've rules Haskell pegs for rules Haskell, a build unit is not a module like it is for GHC. Instead, a build unit is a package, unfortunately. And so because of that, there's this kind of awkward thing where we have to specify what the main file is. And I had accidentally deleted it. So I put it back. I'm getting some zlib error. I think that I had gotten something to build before by adding zlib as a dependency to turtle. And for whatever reason, that's not working now. And it seems like it wants, let's see, stack edge, zlib. Let's take a look at our workspace. We do have the extra depth zlib, and we do have turtle. Maybe I should add zlib here. At this point, I'm just trying random things. I might need to maybe make zlib a dependency of the tests themselves. And actually, while we're at this, let's see if we can find where else turtle is used. So in this Nix stuff, which we will ignore, it's just using it in the tests. It appears in the Cabal file. It's using both kinds of tests. So I might have to do a little bit of debugging to figure out whether it's worth even debugging. I suppose I could try to install system zlib, which I would prefer not to do. I'd rather have the build system manage all of the dependencies. So adding zlib didn't help. Adding zlib to the stackage, the stack snapshot didn't help. I'm going to, I guess let's check if the turtle thing itself builds. Yeah, it's turtle itself that fails to build, even though zlib is a dependency. So I'm wondering, maybe so why is it? I'll do some more debugging. I'll debug this offline. I don't think this is going to make good content. All right, so I figured out that the thing that was failing was Proto 3 Suite, which is another project from the Rules Haskell people. I decided to just install the zlib system library. I may either one of two things will happen. Either I'll drop the dependency on Proto 3 Suite, or at some point I'll configure it properly. But it seems like the rules aren't generating Bazel build files for the stack dependencies. It seems to be doing something else, or maybe they're generating them and just not writing them to disk. But I suspect they're actually using stack to build them. And so there's this weird, we've got multiple build systems going, and we're outside of the Bazel ecosystem. And so I don't know, and I don't think that it's worth my time trying to debug that issue. So I'll just install it as a system dependency and just go ahead. Okay, so now that core builds, let's try building the entire project from the root directory. I'm seeing some stuff about not being able to find Gazelle. I think I saw somewhere that I could fix this by basically moving the Gazelle setup under Go register tool change. Let's try that. Okay, so it says that exited abnormally. And now I'm getting something about network gRPC low level is not a member of hidden package gRPC. It is a member of hidden package gRPC-haskell core in bench. So here's bench. Let's pull it up. And then on the right here, I'll pull up the root workspace, the root build file. And we see that gRPC-haskell depends on gRPC-haskell core. And yet, somehow, maybe bench is supposed to depend directly on gRPC-haskell core instead of only on gRPC-haskell. I don't know. So Gazelle set up this dependency. I'm not sure if Gazelle made a mistake or if the original Cabal file didn't list the dependencies explicitly. So let's try. We're also going to get rid of this nonsense here. Let's try building bench again. And now we are getting what appears to be a type checking error. So I think that Bazel is doing its job, and that maybe these benchmarks are just not up to date. That maybe they don't get exercised by CI, and so they haven't been updated because the automation is not failing. I'm not sure, but these are all like could not match expected type with actual type. I don't know. I don't know really if it's worth my time fixing this. But since this doesn't seem to be a failure with the build system, it seems to be buggy code. So my goal here is to get the build working, not to fix buggy code. So let's just try commenting this out and building from the root directory again. Okay, so now everything seems to build from the root directory, including things like the examples. So I think next step is, just like in my previous video where I went through an example editing a simple gRPC service in Haskell, I'll try to do that again, but using the Bazel tools. I guess one thing we can try to do is see if using the Bazel tools. If we have extra time, I'm not sure we do, I could try seeing if tests run. I'm guessing they will not run. They build. I don't think that they will necessarily pass, considering the failure we saw with benchmark. And I'm not sure they'll even run, as in there may be type issues or runtime issues that are not reflected in the or properly captured by Bazel, or just haven't been maintained properly. It's still running, but we're already seeing that tests have failed. At least one test has failed. Okay, so unsurprisingly, the tests failed, or at least one failed, and the other time's out. We do have a log. But does it not exist anymore? So I can't find simple.proto. And it's looking in tests/simple.proto. So maybe it's because I moved something. So this is generated tests, which is using Turtle. And I think what it's trying to do is generate code. And the thing that's failing is since I moved the target into the tests directory, it is now looking for a simple proto in the wrong place. I'm tempted to just change the file rather than move the thing back. I guess that's easy enough to do to undo. So let's try occur tests. So include dir, I guess we'll change to dot. This one. So let's replace the string test/ replace with quote dot slash. Let's try this. All right, so that builds. Is it testing or building? Compilation, Bazel build. Let's try Bazel test. Okay, we still fail. We have a new test log. Failed to find file, simple proto. It's still looking in test/simple.proto. But why? Let's see if anything else refers to it in that directory. So we have generated tests, we have protalk. Here we go, tests. I'm still looking at test/simple.proto. What happened to my grep window? Will this work? Okay, so now it's looking in the right directory, but it unable to find. Well, it is here. Let's try in a shell. There should be some protalk.sh unbound variable. What is this? So PyTempter. So we can't find can't find gRPC tools protalk. That's a different story. And what about this generated test thing? Hmm. Server generation. So server generation is here. We're going to include simple.proto from the include directory. What if I do /? Does that help? I'm guessing it does not help. enable. Oh, what? Why is it not enabled by default if it's set to global? I don't know. Okay, so now simple.proto. So where's this function? Is it imported from somewhere? .proto generate. Maybe. So let's just try, just for completeness, let's try making the include directory be the whole thingamajig. Okay, still failed. Server generation is still failing. Oh, it seems like client generation is not failing, maybe, right? Let's try making the same change in client generation. So how is it not finding it? What if I, instead of having the tilde, I include my full username? Okay. It seems maybe the whole username is doing it. Hang on. Now I'm getting some exec client, simple client simple client.sh file does not exist. So it seems to like the proto file now. So the problem now is that somehow this code is being executed in the wrong directory. So where was it before? It should have been one folder up from tests. But now it should be executed in the same folder as tests, but it's not finding things in its own folder, I believe. Maybe we can try finding simple.proto in the Bazel sandbox thingy. It is conversation prompting. gRPC tools test. Let's try finding it again, directory up. But that shouldn't matter because yeah, I don't know. Let's try running sandbox debug and see if that'll preserve the sandbox. Query tests. Sandbox debug. Okay. I forget which thing follows links and find. I'll try using capital L and then predicate. How about lowercase l? No? Okay, so it is in Bazel's gRPC-haskell. So let's see what else is in this directory. This seems good. Why can't it? So what do I call protalk here? It should fail because of Python. Okay. Yeah, so the tests are written in things like Python, and they escape the Bazel ecosystem. I'm not sure to what extent this is worth debugging in this mode. I feel like we're a little bit close though. Create process. Yeah, okay, so it's calling GHC from a shell script. It's not very pretty. And I'm not sure what hstempter is supposed to be. I guess it's supposed to be some sort of, I think I saw here, what was it? /temp? /.temp. Is there another, maybe should be /? Oops. Okay. Simple client, create process. Exec does not exist. Okay, so I'm not going to debug these tests because they are not, I don't think it's worth the investment. I will probably use some of the existing code to inform any new tests I write. But again, the root problem is that we are escaping Bazel, doing things we should be doing with rules. The rules Haskell project is doing them with like Bash and Python, and it's just not, to me, it's not worth investing more kind of chasing down all the places that that escaping the Bazel sandbox can cause trouble. What I would like though is if it's possible to build, and by what I would like is if it's possible to run at least one of the servers. It would be nice, for example, if I can run the arithmetic server. And this doesn't look like it's something I can run. Do we have anything runnable? We have Go libraries. What if we do find grep Haskell binary? We have only one Haskell binary. Okay, so now I want to set up some Haskell binary targets. A binary target is what you need in order to run something, to execute a binary rather than just build a library. And for whatever reason, Gazelle Cabal didn't create any Haskell binary targets that correspond to the executables in the Cabal file. So the first thing I'm going to try is just to do the most obvious thing, which is just to create the binary targets by following my nose, not really doing anything fancy. The tutorial places where is where the arithmetic client was that I played with before. So this seems like a good place to start. There is a build file here. And we've got Go protos, which I don't think I care about. I'm not sure why we would want Go protos. I'm not sure why rules Haskell Gazelle Cabal generated it. I don't see it I don't see any Go stuff for the tutorial in the Cabal file, but that's okay. So we do have this proto library. We need a Haskell binary for the arithmetic server. And we need a Haskell binary for the arithmetic client. Now, I believe, if I remember correctly, they just committed the compiled proto to source control. And I don't think that there's proper proto support for invoking the protocol buffer compiler from Bazel. And I'm not going to write a rule at this point to do that. So until I have kind of cleaned up rules Haskell, I think I'm going to just do what the gRPC-haskell folks did, which is to compile the proto and commit the compiled file, perhaps. I guess I'll need to think about whether that's something that I really want to do. But there should be rules for compiling proto files that can be adapted for Haskell, but I'm not sure what that looks like just yet, or if there are other barriers. So, for example, the Haskell, the Proto 3 library that gRPC-haskell is using is this custom rolled protocol buffer support, which is different from the like ProtoLens, which is what Google uses. So I'm going to guess that ProtoLens is set up more to be integrated into the Google ecosystem. And so I'm not sure, again, whether it's worth investing the time into trying to make Proto 3 Suite and Proto 3 Wire nicer, or if it's better just to tear them out and replace the modify gRPC-haskell to use ProtoLens instead. Now, I'm not quite sure what exactly the right dependencies are, but maybe we can take a look at here. Let's try this. Deps equals some list. I'm going to copy and paste, rather paste these. I'll just copy this wholesale to the client as well. There, it's possible that we don't need quite everything, or we need different things. So what do we see? Have async, byte string containers, deepsec, gRPC-haskell. Well, this is not. I'm not sure why we need to depend on gRPC-haskell core as well as gRPC-haskell itself. But we'll see what happens if we don't have it. Text vector. Seems like all the same stuff. Okay, let's see what happens if we try to build, let's say, arithmetic server. Haskell binary is not defined. Okay. Invalid repository name. What have I done wrong? Okay, so arithmetic proto is not declared. Oh, yeah, it is. So I guess wants me to use a dash instead of a. I don't want to use a dash. Oh, I accidentally told it to look for arithmetic proto in the root directory. I meant to tell it to look at this current directory. Okay, so gRPC-haskell with the dash is now wrong. So deepsec is not visible. So why wouldn't deepsec be visible? Seems like it didn't make it into the stackage thing. Okay, similarly, vector is not visible. Anything else? Do we have byte string? Containers, I know we have. Do we have optparse? We do not have optparse generic. Okay, so this is the kind of awkward thing with the rules Haskell rules where we have to specify what the main module is. And I forget how they do it. I think it's like main is or something along those lines. Here's the Haskell binary implementation thing. Main underscore file. And we'll do the same thing for the client. Okay, so that built correctly. That's good. Let's try making sure that both build. Okay, great. Now let's see if we can run. Okay, well, it says we completed successfully, but I'm not sure. I'm not sure it's supposed to exit. Is it running? Let's try exit. Let's try doing it from the a real terminal. Let's try running the client. Oops, it's called Bazel, man. Oh, okay. So the server does seem to be running. And what happens if I kill it? I kill this window, does I kill the process? Excellent. Okay, so Bazel run, the server does work. Bazel run, the client does work. That is great news. Now we are at least at a place where we can build and run services. So the last thing I want to do is just make sure that I commit this to source control. I'll just stage all of the things. Cool. So I'll stop this video there. What I want to do is start building services in Haskell, just playing around, iterating, making some stuff, seeing what works, what doesn't. To do that, one thing I haven't done so far is actually set up a source code repository to work in. Everything's been in this playground thing because I wasn't quite sure if I would be able to get stuff to work. So perhaps the next video or sequence of videos will be setting some of that up, or maybe able to do that offline without recording the videos. I'll see how it goes. But now I think I'm in a place to begin taking the work that I did, cleaning up rules Haskell and gRPC-haskell, and using that as a base to expand from. And I just need a little bit more infrastructure to do that in a way that's not likely to lead to in a way that's reproducible and sane and allows me to make incremental progress.